Hello, senior one. How are you? Today we're going to learn how to write the ionic compound. And as you know that the ionic compound formed from two main parts. The first part, it's called the positive ion or the cation. And the second part, it's called the negative ion or the anion. So any ionic compound, this is called the ionic compound. So the ionic compound formed from two parts. The first is the positive ion, and which is carry positive ion, and it's called the cation, and the negative part, which is carry negative charge, and it's called the anion. How about the positive ion or the negative ion? The positive ion may be an element or atomic group, and the negative ion may be an element, and this element was a non-metal, gain electron and change to the negative ion, and this positive ion may be metal, lose electrons and change to the positive ion. So, for example, if you have sodium, they carry positive charge because the sodium, when it loses the electron, it just loses one and change to the positive ion. And we have the sulfur that gains 2 electrons to complete its outer level and be stable and convert to the negative 2 anion or ion. And we want to write this formula. We couldn't write in this way. If the two numbers here, the positive and negative, are equal, we cancel each other. They cancel each other. So if they are not equal, we're gonna exchange. It means that we have 2 sodium and they react or combine together with the electrostatic force to form the ionic compound and 1 sulfur. And this is called the sodium, and then sulfur called the sulfide. So this is the way we write the formula of the ionic compound. Just write positive at the first. Just write negative at the second. And don't forget to write the valency. Don't forget to write the valency. If they are equal, cancel each other. If they are different, we're gonna exchange the valency without the sign and not exchange the elements. We're gonna exchange the valency of them. It means that we have sulfur gains 2 electrons. They gain 1 electron from the first sodium, and they gain 1 electron from the second sodium, because sodium lose 1 electron and this lose 1 electron to give these 2 electrons to the sulfur that gain 2 electrons from the sodium. That's why we write it Na2S. Okay, so right now we have to learn how to write the different chemical compounds. Sometimes we have what we call polyatomic groups. What's meant by the polyatomic groups? Polyatomic groups, it means they are a group of elements joined together between the brackets as you see here and carry 1 valency. So they are a group of elements that join together and all of them carry a certain charge up here. Like if we have NH4, we have 1 nitrogen, 4 hydrogen combined together to form what we call ammonium. So ammonium carried the positive charge, okay? This is called polyatomic groups. This is called polyatomic groups. We have some of them carry positive, as you see here, and most of them carry negative, or almost all of them carry the negative charge, like the hydroxide, which is carry -1, like the carbonate, that is carry -2, like the sulfate, that is carry -2. So they are called polyatomic groups. So when it comes to combine a metal with a polyatomic groups, suppose that I write you sodium carbonate and ask you to write the chemical formula for the sodium carbonate. We write here sodium, that is carry positive charge when they lose electrons, and carbonate, it's a polyatomic groups that is carry -2, and because they are not similar, we not erase it or we will not cancel each other. But we have to exchange. So 2 goes here, 1 goes down here. It's Na2, CO3, all have 1. We don't try this one, okay? Let's do, here in our booklet, we have some of the cation and we have some, and their valencies, and some of the anion with their valencies. First, they are the cation with the positive ion. We have the elements that carry positive 1. It means that they lose 1, change to their positive ion. And we have the valencies of the elements that carry positive 2. And the polyatomic groups, as I told you, almost of them or all of them carry the negative charge, except the ammonia carry the positive charge, ammonium NH4, while the acetate, nitrate, nitrite, as you see here, perchlorate, hydroxide, chlorate, all of them, they react or they are going inside the reaction as one unit. So let's solve some of the question here in our booklet. We have the exercise here. Lithium chloride. How could we write the lithium chloride? I'm gonna write it here. It's lithium chloride. Write Li with positive charge, chloride Cl with negative charge. They cancel each other, so it's LiCl. Next, ammonium permanganate. So ammonium, it's a polyatomic group that's carry positive charge. Permanganate, MnO4, that is carry negative charge. Between the positive and negative, they cancel each other. So this is called ammonium permanganate. Silver phosphate. Iron, it's Fe with a positive 3, because here we write 3. Phosphate, it's the polyatomic group with negative 3. Because we have here 3 and 3, they balance each other, so the valency will become 0. We cancel them. How about the next? Copper, 1 iodide. Copper is Cu with a positive 1. Iodide is I with a negative 1. Positive 1 with negative 1 cancel each other. So we're gonna write copper iodide like CuI. Next. We have here tin fluoride. Tin fluoride. What this number means. 1 in Latin written in this way. It's 1. 2 in Latin written in this way. 3 in Latin written this way. 4, this represents 5. Before 1, it's 4. And then 5. So this means that the 10 carry positive 4. Fluoride F carry negative 1. Because they are not equal, we're gonna exchange. So Sn take the 1 and F take the 4. This here. This is 5, 6, add this, 7, add this, 8, like this. Let's try to solve this equation together. Suppose that you have an equation like sodium chloride plus lead nitrate to give you partner. So we're gonna exchange because this is a kind of substitution reaction. So it's sodium plus lead to chloride. Let's change this symbols into a chemical formula. Let's change this symbols or this names into a chemical formula. Sodium chloride, it's Al. Lead to nitrate, it's PP. Nitrate NO3. This has 2, this has 1. We're gonna exchange. It will be in this way. Sodium nitrate, it's Na, NO3. Lead chloride, it's PPCl. Here we have 2, here we have 1. We're gonna exchange so you get this. To write the molecular formula, you have to know that one of this will be salt, or it means precipitate. It doesn't dissolve. The lead chloride, it doesn't dissolve. It's salt. It's a precipitate. So first, before we go, we have to balance our equation. We enter with Na, sodium, 2 sodium, and 2 chloride, 1 pp, 1 pp, 2 NO3, 2 NO3. So it's balanced. Let's write it. 2 will take the carbonate. Come on. Sodium carbonate, it's NaCO3. We have 1 here, we have -2, so exchange. 2 goes down here, plus iron 2, Fe, chloride Cl, here 2, here 1, exchange, 2 goes down. Sodium chloride, NaCl, 1 and 1 cancel each other. Iron carbonate, Fe positive 2, carbonate CO3 negative 2 cancel each other. Make sure that we balance our equation first. We have here 2 sodium, so we have write out in the coefficient place 2. So we have here 2 sodium, 2 sodium. 1 carbonate, 1 carbonate. 1 Fe, 1 Fe, 2 Cl, 2 Cl. It's balanced. Don't forget to write that all the carbonate salts doesn't dissolve except the ammonium, potassium, sodium. So this is a kind of salt or precipitate. We're gonna write here aqueous. How to divide it? We have Na positive, CO3 negative, Fe positive, Cl negative. We have here 2 sodium, so we'll write here CO3 carry negative 2, Fe carry positive 2, and the chloride negative 1. But here we have 2, write down. Out. We have Na positive, Cl negative, but here we have 2 common factor, so it's 2 and 2. This is solid, we'll keep it as it is. Let's cross out. Before we cross, we have to write the aqueous. Cross out these spectator ions. It's Na, 2Cl, 2Cl. So CO3 negative 2 plus Fe positive 2 to give FeCO3 salt aqueous. This is called the molecular. This is called the complete ionic. This is called the net ionic. Thank you for now.